শোনা যাচ্ছে সমস্ত? Is the screen visible? কত অবধি করানো হয়েছিল একটু মনে করো তো? How much did we complete in the last class?
দাদা মিউট করা।
ধ্যাত্তারি, কথা বলে যাচ্ছে। হ্যাঁ, বলছি যে how much did we cover in the last class? Till the last class. Did we do 3.3? I mean, the last class was, I think, 2 weeks back. So, did we start doing 3.3 isomorphism? Did we do it? I don't know whether you were even looking at the notes or not. I mean, both the things are unacceptable. I mean, if you are looking at the notes, if you know how much we have done and you're still not replying, then it's quite bad. And if you don't know at all, then it's not good either. 12 B is an cross and matrix. 12. Yes, we completed this. Okay, so today we start 3 isomorphism. তুই কোথায় গাবজাল দিচ্ছিলি? হ্যাঁ তিয়াসা, কখন থেকে ডাকছি?
হ্যাঁ দাদা, বুঝতে পারি।
Okay, what is an isomorphism? An isomorphism is a linear map such that it is bijective, and automatically you will see the inverse map is also a linear map. I think we have proved it that if T is linear, T inverse is also linear if T inverse exists. So if T is a bijection and linear map, we call T an isomorphism. Now see, this is a very important theorem. This is basically a characterization of vector spaces of dimension n. This says every n-dimensional vector space over the field F is isomorphic to f to the power n. This is pretty easy. To prove this, we basically construct a map and check that this is an isomorphism. So they have given a basis of V, and what is the natural basis of f to the power n? What is the natural basis of f to the power n? Consider epsilon E1 থেকে En, where Ei is 0 0 0 1 at the ith place, rest 0. This is the standard basis of f to the power n, right? So any element in f to the power n looks like xn. Okay, so define a map phi from f to the power n to v as follows. You send x1 to xn to summation xi alpha I from 1 to. Check that phi is a isomorphism. So this is pretty basic stuff. Okay, let's see what they are doing next. So they are just the right next to it is the exercise. I'd request you to go through this part. See, this is why a good theory book is important. You can get all the statements of the theorems and the proofs from the internet. You can get exercises from the internet. But then what is the need of a good textbook? A textbook is because of its order, the order in which the theorems and the lemmas and the exercises are there, and a textbook is needful because of these discussions. You will see, I mean, across the book, what Hoffman Kunz do is they basically give you some idea in those discussions, and then they formalize the idea in a proof. So never skip these discussions. Okay, please go through it, and then we will move on to the exercise. You have 3 to 4 minutes. Please go through it. পড়া হলো? Are you done? Then we will move on to the exercise.
দাদা একটু বুঝিয়ে দাও না, মানে বুঝলাম অল্প অল্প, কিন্তু পুরোটা বুঝলাম না।
For many purposes, one often regards isomorphic vector spaces. এটা কে বললি? অনুভব?
হ্যাঁ,
আচ্ছা, টেক্সট বই ধরে ধরে পড়ার অভ্যাস তৈরি করতে হবে। হ্যাঁ, একবার না বুঝলে তিনবার পড়তে হবে, সেইভাবে বোঝা যাবে।
ওকে দাদা।
না না, সে বুঝতে না পারলে তো ডিসকাস করতেই হবে। For
না না,
many
লাস্টের
purposes,
দিকেরটা একটু ভুলিয়ে গেল।
কোন পার্টটা?
লাস্টের দিকে
দেখছি।
একদম।
For many purposes, one often regards isomorphic vector space as being the same. Although the vector spaces operation in these spaces may be quite different. We shall make a few brief comments. Suppose T is an isomorphism of vector space into. If S is a subset of V, then theorem 8 tells us that S is linearly independent if and only if the set Ts in W is independent. Thus, in deciding whether S is independent, it doesn't matter whether you look at S or Ts. From one sees that an isomorphism dimension preserving.
এই ম্যাট্রিক্সের ব্যাপারটা, ফার্স্ট দিস ফার্স্ট ইজ দ্য সেট অফ এন টাপলস, এটা কি রো ম্যাট্রিক্স, তারপরটা কি কলাম ম্যাট্রিক্স ধরেছে, দুটো আলাদা আলাদা। ওখানে সলিউশন বলতে চাইছে, মানে রো স্পেস, দুটো সলিউশন স্পেস বলেছে। ওটা কি রো স্পেস সলিউশন আর কলাম স্পেস সলিউশনের কথা বলছে?
Kontare? Which one? The first is the set of. Here a very simple illustration of the same dimension is under T. Suppose A is an
উইচ
m
আর
cross n
রিয়েলি,
matrix. We have really given two definitions of the solution space of the matrix A. For the set of n tuples,
এই লাইনটা
the
we
first
have
is
really given two definitions of the solution space of
space
the
of the
matrix.
matrix A. The first is the set of all n tuples x1 to xn in Fn which satisfy the equation this. The second is the set of all n cross n column matrices such that Ax is 0. Okay, so why you are asking why are these two different, right?
না, এই দুটো কি, মানে এই দুটো কোন মানে কোন স্পেস দুটো? একটা রো স্পেস, একটা কলাম স্পেসের কথা
No,
বলছে
no, no,
কি?
no, no, no. They are giving the set of the solutions in two different ways. One is that the set of all n tuples which satisfy the equation Ax equals to 0. And second is the set of all n cross 1 column matrices of X. These are basically same, okay? I mean, there is not much difference.
একটা রো ওয়াইজ বলছে, একটা কলাম ওয়াইজ বলছে, এরকম এরকম। ওই সেম ম্যাট্রিক্সটাকেই তো একবার মানে x1 x2
Basically.
xn একবার রোতে একবার কলামে, তাই তো?
Basically.
হুম, আচ্ছা আচ্ছা।
Just give me a minute. এখন করিস না, শোন তুই হোয়াটসঅ্যাপ কর না, আমার আসলে ক্লাসটা চলছে। হ্যালো, বলছি যে ইয়েটা কর, ওই কি বলে, তুই একটু হোয়াটসঅ্যাপ কর না, আমার ক্লাসটা চলছে আসলে, আমি এটা বিয়ে করতে পারবো না। হ্যাঁ, আর এটা রেকর্ড হয়ে চলতে হবে। Hello. Okay, so let's move on to the exercise. Okay, so we will be discussing, let V be the set of complex number and let F be the field of real numbers. Uh, Describe explicit isomorphism of. Okay, I think you can do it. This is pretty easy. 2 is easy. I mean, think when I am saying these are easy, it might not be easy for you. You can try this at home, of course. W set of complete Hermitian matrices. V be the set of complete vector spaces regarded as the vector space over the field of real numbers. We define a function t from V into the spaces of a 2 cross 2 real matrices as follows. Okay, so verify tz1 z2 equals to tz1 tz2. These are basic stuff actually. I think you can do it. VW finite dimensional vectors prove that. Okay, do 6 and 7. Do 6 and 7. At least try it for a while.
মানে ৬ আর ৭ এরটা চেষ্টা করতে বললে?
অবশ্যই।
বলছি ৬ এরটা বলবো একবার একটা মানে একটা সাইড।
বল না, নিশ্চিন্তে বল।
হ্যাঁ, হ্যাঁ, ভিটা যদি ডাইমেনশন n ধরে নিই তাহলে ভিটা কোনো একটা আরএন এর সাথে বা এফএন এর সাথে আইসোমরফিক, আর ডাব্লুটা হচ্ছে এফএন এর সাথে আইসোমরফিক, তাহলে ভি আর ডাব্লু হচ্ছে ডাইমেনশন দুটো সমান হলে তারা দুজনে আইসোমরফিক হবে। তারপর দুজনে আইসোমরফিক ধরতে হবে।
Well, she has given a proof. Let's write it down. Prove that V and W are isomorphic. Okay. So let uh, dimension. So let V is isomorphic to W. Okay. Now V is isomorphic to f to the power n, where n is dim V. We have just seen above. W is isomorphic to f to the power n, where m is dim W. Okay. So f to the power n isomorphic to V, isomorphic to W, isomorphic to f to the power m. This implies m equals to n. Okay. Dimension V equals to dimension W. And it's the same thing. I mean, if just do this, if dimension V is equals to dimension W, call it m, call it n. Sorry, just do the reverse. Okay. Okay. ঠিক আছে? Is it okay? Let V and W be vector spaces over the field F and U be an isomorphic. Tell me how to proceed. Shaurya, why are you so silent in the class?
नहीं भैया, क्या बोलूं? पिछली थ्योरम आ गई थी भैया समझ में।
Okay, but at least contribute. You are not a bad student. You are able to contribute. I know your potential. Let V and W vector spaces over the field F. U be an isomorphism from V to W. Okay, so here the street dogs have started a concert. Prove that T going to U T U inverse. Okay, so this is an isomorphism. Okay, now they are defining a linear map from LV to V. What is LV to V? That's linear map from V to V, also denoted by LV. This is also denoted by LW. They are defining a linear map by T, sending T to U T U inverse. Okay. First, we have to check whether it is a linear map at all. So let's check.
এটা কি এসইউ লেখা আছে?
This is S and this is U.
হ্যাঁ হ্যাঁ ঠিক আছে।
Uh, U lambda T U inverse plus U S U inverse. That is lambda will bring out because lambda will come out because lambda is multiplied with the matrix. U T U inverse plus U S U inverse, which is lambda. Okay, so this is a linear map. Is it a bijection? Is it an isomorphism? What should be the inverse of phi u? Please tell me somebody. please at least you should be able to contribute that why should phi u be an isomorphism. What should be its inverse? There's supposed to be an inverse, na? What about this? That LWW2. So U inverse is from W to V, right? So let's define U inverse. And what do you get? So U inverse is sends just if n is a linear map, U inverse will send it to U inverse n U. Okay. What is phi U compose phi U inverse of n? This is nothing but phi U of U inverse in U. It is nothing but U inverse in U. These are very natural choices. I don't know why all of you are so silent. I can't come up with a more natural choice. I mean, if phi u is this, phi u inverse is, it should be like this. Okay, so these are identity. So phi u compose phi u inverse is identity of what? Identity map of identity W, and phi u inverse compose phi u is identity V. So we are done. Just that's it. Okay, this is a very important chapter because we often use this association between a linear map and a matrix between two finite dimensional vector spaces. Here we are actually formalizing that relation. Okay, so they are saying that if V is an n-dimensional vector space over the field F and W is dimension F, beta is a given basis of V and beta prime is a given basis of W. T is any linear transformation from V to W, each of the n vector. And so basically what they are doing is they are evaluating T at the basis of the domain and writing those images with respect to the basis of the codomain, right? Here it is, T is evaluated at alpha j and written in terms of beta i's. I would request you to read this thing from 3.4 from this to this theorem actually. Not only to this theorem, because this is actually, I mean, till this. Basically what they are doing is that they are writing, I mean, I think we all know that suppose V to W is a linear map T, V has a basis alpha n, call it beta, so this is beta 1 2. Am I consistent with the notations? Call it beta prime. Then what is T alpha 1? It should be T I beta I, so A 1 beta 1 plus A 2 1 beta 2 A m1 beta m, so on. Right. T alpha j is like a I 1, sorry, a 1 beta 1, sorry, a 1j beta j, a 2j beta j, a nj beta n, and so on. T alpha n is of course a in a1n Okay, so if you look at it, these coefficients form a matrix, right? What is the coefficients if you just write them down? See that this is A transpose, right? Where A is Aij, right? Sorry, Aij. So we can actually say that A is the matrix of T with respect to this. So we write T beta, what is the order? Is the domain written? I mean, A is the matrix of A with respect to beta and beta prime. That's what I am trying to say. Okay, so sometimes they write like this. Okay, so this is something they have just formalized. I'd like you to go through it. I think all of you have the book or the PDF, right? So you have 5 to 6 minutes, 5 to 7 minutes. This is this page and come to this theorem 12. Okay. দশ মিনিট আছে একটু দেখো I won't be spoon feeding you. You'll have to go through some stuff yourself. How far did you go? Have you done reading it?
orange,
হ্যাঁ দাদা হয়েছে।
Okay, so we are going to do this now. We shall particularly interest in representation of matrices of linear V, matrix relative to the order basis. Okay, so see, this is an example. This is a projection map, right? Projection onto the first coordinate. Here they have come up with the matrix of this projection map with respect to the ordered basis. Let V be the space of all polynomial functions. Okay, this is also a very important example. See, this example is also very important, where it is the differentiation is probably the linear map, and this is the example. They have taken the basis by 1 x square x cube. So this is the matrix. Again, you have just you can just see what they are doing. They are taking the basis, evaluating if at evaluating D with respect to that basis, and writing down the matrix. rows or columns, one sees a very strong motivation for defining the definition to be found a composite linear. Okay. This is also a basic theorem, I think. Please see the statement. V and W be finite. V, W, and Z be finite dimensional vector spaces over the field F. Let T be a linear transformation from V on to W. U a linear transformation from W into Z. If beta, beta prime, and beta double prime are ordered bases for the spaces V, W, and Z respectively. If A is the matrix of T relative to the pair B, beta prime, and B is the matrix of U relative to the pair of the decomposition UT relative to the pair. Okay, so basically the composition composition of linear maps, they have the matrix representation as product of the matrix of each linear map. You can go through these things at home, I think. Okay, this is a very important thing. For every vector alpha in V, it is the matrix Okay, this is very important thing. See what they are doing. They are basically doing a change of basis. Okay, so suppose T is a linear map. T is represented. T is a linear map from V to V. T is represented with respect to some basis. Now it is being represented with respect to some other basis. So what will be the change of basis matrix? Please read this. These two. Please read till this. Okay. Shaurya, are you following?
हाँ जी भैया.
So theorem 14 and the discussion before it. This is the change of basis stuff. Please go through it. I mean, you will have at least one problem in the net from this. Please go through it. Tell me when you are done. রোদেও তো দেওয়া যাবে না, মানে বৃষ্টির চোখ করে। Let me know when you are done, so then I can proceed. But don't be in a hurry. I mean, if you read the theory by yourself at home, then probably we can actually pick up the pace. Because these things, I think you can actually do it on your own. I mean, Hoffman is not Rudin, actually. Hoffman, Moncrief, these books, these books can be actually read by the student himself. This is not Rudin, where you need a guidance. Actually, Rudin is too precise sometimes. Tell me when you are done. তিয়াশা কত দূর? তিয়াশা, অর্পণ, অনুভব হলে বলো, এগোবো। এই জন্য আমি বলি থিওরিটা বাড়িতে পড়ে রাখতে, নাহলে ক্লাস বোরিং হয়ে ওঠে। ধীরে সুস্থে যাও, চাপ নেই। We will discuss this today. Okay, let's see. Tell me when you are done. Basically, the change of basis matrix will be P inverse AP, nothing else. Tell me when you are done. ইয়াশা কদ্দূর? অদিতি, হাল কি?
হ্যাঁ বলো, করছি আর কি।
হ্যাঁ দাদা, হয়ে গেছে আমার।
Okay, so here are some examples are there where they are actually they are considering first of all Tx1 x2, it is the projection map, and the matrix with respect to 1001 is 1000. Now beta prime is another ordered basis of R2, it's 1121. Now they are trying to compute the change of basis matrix. What is that? See, they have basically written the new basis in terms of the old basis, and P is the matrix, and its P inverse AP is basically the matrix of P with respect to the new basis. Okay, this is just computation. The same thing here they are doing here. Example 17, we had already seen the matrix, it was 0 1 2 3. I mean, for the differential operator, I mean, that was the matrix there. Wait a minute, where was the matrix? Yeah, this is the matrix for the differential operator with respect to the basis 1x x square x cube. Now they are changing the basis of the same operator. is the example. I think they are changing the basis from x to the power I to x plus t whole to the power I minus. Okay, so the next thing we do is, yeah, P. There is a definition of similar matrices. We are going to do a lot of things with these definitions. A, B are square matrices over the field F. We say that B is similar to A over F if there is an invertible matrix n cross n matrix over F such that B is P inverse AP. C. So already you have seen that, so two matrices of the same linear transformation with respect to different bases. Suppose T is a linear transformation. A is the matrix of T with respect to the linear transformation beta, and say A prime is the matrix of T with respect to the basis beta prime. Then A and A prime are similar matrices because there exists P inverse, such a P which is invertible, and the change of basis matrix. And also you can observe that it's an if and only if condition, that if there is a linear transformation, if there is a matrix P inverse AP, then A and P inverse AP are both, they represent the same linear transformation with respect to different bases. Okay, যে P inverse AP আর A এরা বেসিক্যালি সেম লিনিয়ার ট্রান্সফরমেশনই ম্যাট্রিক্স উইথ রেসপেক্ট টু ডিফারেন্ট বেসিক্স, যেখানে চেঞ্জ অফ বেসিস ম্যাট্রিক্সটা হচ্ছে P। ঠিক আছে, okay, this is a very important thing I think here. Read this thing please. According to theorem 14, we have the following: if V is an n-dimensional vector space over F, beta and beta prime are two ordered bases of V, just what I told you. So B is a T beta with respect to beta prime is similar to the matrix T with respect to beta some other basis. The argument also goes in the other direction. That you see, they have just written what I was saying. Let V be any n-dimensional vector space over F, and beta be an ordered basis for V. Let T be the linear operator on V, which is represented in the basis beta by A. Then B equals to P inverse AP. If B equals to P inverse AP, beta prime is the ordered basis of V obtained from beta by P. That is this. Okay. Then the matrix of T is the ordered basis of beta prime will be B. Okay. So they have come up with a basis such that T represented with respect to that basis is P inverse AP. Now see, this similarity is an equivalence relation. Okay, this is transitive, symmetric, and reflexive. Read this paragraph. This relation is written here. Read this paragraph, please. Any n cross n matrix is of course similar to itself. Then because you can take P equals to I. Read this paragraph just. Okay, done reading it. Done reading it. So we will do some.
হয়ে গেছে
Please do all the problems. At least first 50-60% of the problems are doable, and these are small exercises. I expect you to do the complete. Expect you to complete it. You are getting almost 7 to 10 days to complete an exercise. You should be able to do it. What will we do basically? We will discuss this in the next class. Okay. Number 8 we will discuss. Number 9, of course. Number 10, 11, 12. These we will of course discuss in the next class. 13. Yes, this will be discussed in the next class, but at least you should try. Don't think that since these are going to be discussed in the next class, so let's not try. Complete the exercise. Okay, so that's it for today. You have to read the theory by yourself, otherwise we can't pick up the pace of the class.